physics, the atom. So for this problem, we don't exactly have a problem. We're just going to go ahead and explain a little bit about what the atom is, how it's comprised. So for an atom, you basically have two major components. You have the nucleus, which is made up of protons and neutrons, and then you have the electron cloud, which surrounds the nucleus, and it's full of electrons. So electrons are basically negatively charged particles. They form orbitals or shells around the atom. You learn a lot about these orbitals and shells when you were in chemistry. And the electrons inside of this shell, they repel each other. And this would regularly cause the electrons to scatter. However, these electrons are held in their orbitals by the positively charged nucleus at the center, because the protons are positive. So the nucleus is the most dense part of the atom. It contains almost all of the mass inside the atom. The electrons have a little bit of mass, but not very much when comparing to the neutrons and protons. So it's incredibly dense, and it takes up a very small volume when compared to the rest of the atom. One example that I've seen is that it's basically the equivalent of if you have a football field and you put a dime into the middle of the football field, that would represent the nucleus, and then the entire rest of the football field would be the rest of the atom. So very, very small when in comparison. So again, the nucleus is positively charged. It's comprised of protons and neutrons. The positive charge on all of the protons causes them to repel each other. The neutrons, however, they're not negatively charged. They're uncharged particles. The force that would regularly cause the nucleus or like protons to scatter from each other is called the electromagnetic force. However, when you get down to distances that are inside of the nucleus, so very, very short distances, a new, bigger force takes over, which is called the strong force. The strong force, it acts over incredibly small distances, however, is much, much stronger than the electromagnetic force, and this keeps the atom bound together with the neutrons and the protons and keeps them from scattering away from each other. So once you get into larger atoms with larger nuclei, such as radioactive materials such as uranium or plutonium, stuff like that, you end up with a very large nucleus, and when that happens, the strong force in the nucleus isn't necessarily large enough to keep the atom stable, and so it starts losing neutrons and protons